Today we're going to learn a method for factoring trinomials. Trinomials most commonly appear, at least in the beginning, as a quadratic in standard form where you have an ax squared, a bx, and a c. And it comes from the prefix tri, which means 3. So you have 3 terms together, which form what we'll come to know as a polynomial. But our goal is going to be to rewrite this standard form quadratic in intercept form as a product of 2 binomials being multiplied together. So our goal is to go basically and do the reverse of what we did when we were multiplying the binomials together to get standard form. I do want to remind you, and if you haven't watched the video on multiplying binomials, I strongly recommend doing that before seeing this video. In that video, we talked about how when you expand and you multiply 2 binomials, your first 2 terms, the ones in red, would multiply to give you your first term and your ax squared term. Your last 2 terms, when you multiply them, would give you your c term, the blue terms. And then it's a combination, and that's why it's purple, because you're mixing the red and the blue, of their outside terms and your inside terms that give you the 3x. Notice that this x multiplied by this 2 is 2x, and this negative 5 multiplied by this x is negative 5x. And when you combine 2x and negative 5x, that's where you get your negative 3x from. So the term in the center, the purple, is really a mixture of the factors of x squared and negative 10, then added together. We're going to use the fact that this pattern occurs in order to factor trinomials. So the first step is to, if it's factorable, set up the 2 parentheses in which we will write the binomials. Now this is the way that I want you to think about it. X squared is a product of 2 things. Now what do those 2 things have to be in order to go inside of my binomial? So being x squared, the coefficient is 1 and it's kind of prime, so we would just call it 1x times 1x. Alright, now here's where it starts to get a little tricky. We need factors of negative 6 to go in the second positions in the binomials. But there's more than one factor pair for negative 6. We could do negative 6 and 1, we can do negative 1 and 6, we could do negative 3 and 2, or we can do 2 and negative 3. So our goal is to figure out which pair, when I place them in the second position in each of the binomials, will end up giving me this middle term of negative 5x. So what you can do initially is just process of elimination. Try the negative 6 and the positive 1. Let's see if this works. All right, positive 1 times x. This term will give me 1x. I'm actually going to write it in this thing. So these 2 right here give me 1x. These 2 right here give me negative 6x. And when I combine then 1x and the negative 6x, I end up getting the center term of negative 5x. So actually, I got really lucky. The first factor pairs that I tried ended up working. This right here is this trinomial in factored form. If I were to expand this, and I'll just show you really quickly through expansion, x times x would give me my x squared, and then the outside, the last 2 terms, negative 6 times 1 gives me my negative 6, and then the combination of the insides and the outside, so 1 times x is positive 1x, negative 6 times x is negative 6x, 1x and negative 6x will combine to give me my negative 5x. Once you factor, you could always expand again to make sure that you did it correctly. Alright, let's try another one more complicated, because in this case our leading coefficient isn't 1, it's 3. So again, our goal is to rewrite this as 2 binomials being multiplied together. It's called factored form because in factored form you are multiplying 2 things together. And we will get into the most factored form we can later on. Alright, so we know that the first 2 terms in our binomials must multiply to 3x squared. Again, 3 being prime, this is a really nice setup. It has to be 3x and x. Now the last 2 have to multiply to give me negative 4, and again I have options here. I get negative 4 and 1, negative 1 and 4, negative 2 and 2, and again if these were reversed. Okay, so it's just guess and check time. Let's try plugging in and seeing what works. So if I did, let's do the bottom ones first. If I plugged in negative 2 here and positive 2 here, does this work? 3x times 2 is 6x, and negative 2 times x is negative 2x. So I get 6x, negative 2x, which gives me a 4x in the center. Okay, not what I wanted. If I switch the signs on these, just to see if that will work, we'll end up figuring out whether we got the right set of binomials. So 3x times negative 2 is negative 6x, and 2 times x is 2x. Negative 6x, positive 2x is negative 4x. Still no. In fact, if you leave the exact same numbers and switch the signs, the magnitude of the number does not change, it's just the sign changes. So we went from a positive 4x to now we have a negative 4x just by changing the signs. Okay, so what we've actually done, this has not been in vain. We've actually eliminated this as being a possibility for being the factors of negative 4 that go inside the two binomials. So let's try negative 1 and 4. Let's try negative 1 here. Let's try 4 here. These two would give me 12x in the center, and then this would give me negative 1x in the center. If we combine 12x and negative 1x, we'll get positive 11x. Well, we're looking for 11, but we need the 11 to be negative. So what that means is we've actually found the right numbers in the right position, but the signs were wrong. So if we change this to a plus, oops, I don't know what that is. Let's try that one again. We change this to a plus, and we change this to a minus, we'll end up getting negative 12x, positive 1x, which gives me my negative 11x in the center. Let's just expand to see if we got that right. It should be right. 3x times x is 3x squared. 3x times negative 4 is negative 12x. 1 times x is positive 1x, and then 1 times negative 4 is negative 4, and then when we combine all of the common terms in the center, this ends up being negative 11x, and then my 3x squared and my negative 4 doesn't change. Okay. So again, we pick the first factors that work here, and then factors, and sometimes it's just process of elimination, trying switching around the orders and making sure we get that middle term correct. Notice the reds and the blues will always be correct, but we need to make sure that that purple term in the center is also correct. Let's move on to a more complex one. So in this case, again, if I'm trying to factor it, set up my parentheses, I have options. 4x squared can be written as 2x times 2x or 4x times 1x. So what do? Pick one and see if it works. And if nothing works, you can always go back and switch the 2x and the 2x to 4x and 1x. Factors of 6. Let's see, 6 and 1, 3 and 2. And then we can always reverse these if we want to. All right, let's see if any of these work. Let's try 6 and 1. So plus 6 plus 1. This would give us 2x plus 8x in the center, 2x and 12x in the center. So 2x and 12x would give me 14x. I need to get to 11, so it looks like 6 and 1 might not work. And if I reverse the order, it doesn't actually change anything because I'd just be taking this whole parenthesis and this whole parenthesis and then interchanging them, which doesn't do anything. So looks like 6 and 1 are out, at least if my first two terms are 2x and 2x. Let's try 3 and 2. Oops, again, that little guy keeps coming up. Alright, let's try this blue guy. 3 and 2, so plus 3 and plus 2. Alright, so if we do this, this would be 2x times 2, which is 4x, 3 times 2x, which is 6x. So we have 4x and 6x. 4x and 6x would add together to give me 10, not 11. Alrighty, and again, if we switch to 2 and a 3, nothing's going to change very much, so we've exhausted all of the options for the factors of 6, and nothing has worked. So maybe we should reconsider the 2x and the 2x and try something a little bit different. So this time, we're going to write it as 4x and 1x. Yes, it's a little bit of process of elimination. I just erased something actually kind of neat. Let's go back. So again, 6 and 1, 3 and 2, and we're going to try these until we can get that 11x in the center. Alrighty, let's try the 6 over here and the 1 over here. So this would give me 4x times 6, which is 24x. Ooh, that's a little bit too big, and then 1x. So that's obviously not going to work. Let's undo that. What if we switched where the 6 and the 1 was? So if I put the 6 over here and the 1 over here. So 4x times 1 is 4x, 6 times 1x is 6x, so that gives me 10x, again, not 11. Okay, once again, we've eliminated 6 and 1 as being factor pairs that will work. Okay, so let's try 3 and 2. Let's first try 3 here and 2 here. So 4x times 3 is 12x, and 2 times 1x is 2x. So we have 12x and 2x, which is 14x, again, not what I want from the center. Okay, what happens if we reverse them? So instead of putting the 2 first and then the 3, we put the 3 here and then the 2 second. Okay, let's try this. 4x times 2 is 8x, and then 3 times 1x is 3x. 8x and 3x, I finally have my 11x. Let's just check it by actually distributing in full. So 4x times 1x is 4x squared, 4x times 2, let's do it in purple, is 8x. 3 times 1x is 3x, and then 3 times 2 is positive 6. And lo and behold, if we combine our like terms here, we end up getting that 11x in the center that we wanted. Alrighty. So let's make sure we have it. Just do one more, and then I think that will be all set. Let's move on to 6x. Ooh, big one. Alrighty. Let's do it. Sometimes just a little process of elimination, a little luck, will be fine. All right, 6x squared. So I can either write that as 6x times x or 3x times 2x. I'm going to start with 3x times 2x. 12. A lot of factors for 12. We have 12 and 1. We have 3 and 4. We have 6 and 2. All right, let's start with 6 and 2. So let's do 2 here and 6 here and see what we end up getting. All right, this is 3x times 6x, which is 18x, and then 2 times 2, which is 4. So we have 18 and 4, which is 22. Doesn't give me the term in the center that I want. All right, what happens if we reverse them? Let's see. So we're going to do plus, oh, it keeps coming up. That yellow guy keeps getting me. We're going to do the plus 6 over here and the plus 2 over here. So that gives me 6x and 12x. 6 and 12 is 18x, not 17. Okay, so that one doesn't work. Let's get rid of the 6 and the 2 as being possibilities, and we'll just try the 3 and the 4. All right, so let's try the 4 over here, 3 over here. 3x times 3 is 9x, and then 4 times 2 is 8x. So a 9x and an 8x gives me 17. Ah, right number. However, I ended up with a positive 17. Positive 9 and positive 8 is positive 17. My middle term has to be negative. No biggie. What that means is that the numbers are correct and in the right spot, but their signs need to change. So they were both positive. I need to make sure that they are both now negative. Let's expand that and just make sure that all works. 3x times 2x is 6x squared. When I multiply 3x times negative 3, it's going to combine and make purple. That's negative 9x. And then the negative 4 times 2x is negative 8x. And then the negative 4 times the negative 3 is positive 12. And if we combine those terms in the center, we end up getting that negative 17x that we've been looking for this entire time. Alrighty. Well, this is just one of those things that the more you practice it, the better you get at it. Eventually, you might actually be able to see it in factored form and check it fairly quickly without having to list out all the factor pairs on the side. But for right now, you can use this as help to get you that middle term. Alrighty? That's it for today.